Welcome to our demo on Intelligent Computer Science lecture notes. I will demo an architecture that allows us to use the knowledge from our lecture notes for smart information retrieval as well as interactive browsing. Let us start with a traditional slide of a lecture presentation that is done in normal LaTeX. You will see that this is quite presentation oriented. Here is, for example, the markup of a definition and of an example on this slide. That is simply done by making the text bold, and also the mathematical formulas are rather written by what they look like rather than what they mean. So this is merely a sequence of mathematical symbols. For creating PDF presentations and handouts, that is nice because it gives us high quality output, but otherwise we cannot do that much with it. We would be interested in providing more intelligent services from our collection of more than 2,000 slides. And in fact, we are able to do this. So we want to serve the information needs of students and lecturers in a better way. Like consider, for example, a student who spots a strange mathematical symbol in a complex formula and wants to know what that is, how that symbol has been defined. Or imagine a student who is looking for an example that explains a complex concept, or a student who is looking for sample exercises to rehearse the topics of the last week. On the other hand, think of lecturers who are in need of the next topic to cover in the lecture. That could be a topic that has a minimum set of prerequisites. That is basically everything that has been covered so far, but the new topic would not need any additional prerequisites. Or think of a lecturer who wants to introduce a new concept, as for example trees. When the students already have background knowledge on operating systems, it might be good to start with an example about directory trees in a file system. But when the students have background knowledge about dealing with graphs in a formal way, it might be better to introduce trees the formal way. Or think about generating exams. So when the lecturer is looking for suitable exercises for an exam, not too many, not too easy, not too hard, but having a good coverage of the topics of the lecture. So here we have an architecture that is able to deal with that. We do not simply write presentation-oriented LaTeX as I showed it before, but we annotate our LaTeX documents semantically, and then we commit them to an installation of TNTBase, which gives us an intelligent repository and enables services that I'm going to demo now. This is now the same document that we saw before, but not written in presentation-oriented LaTeX, but semantically annotated using our stage macros. So we say that this is not just any document, but it is a module of our lecture, as you see here. And this module, here in this case the properties of relations, this module imports other modules, that is, it reuses the definitions that have been made in these other modules. And here we have a definition, so not just any paragraph, but a definition with some identifier. And here we have an example for that definition. And the mathematical formulas are not just sequences of presentation-oriented symbols, but they are trees where operators and functions are applied to arguments. Like for example here, we say that we construct a tuple of B and A and say that this tuple is an element of the set R. From this stag, we generate omdoc, which is semantic XML markup. That is just because that is much easier to process for machines, whereas this is relatively easy to author for humans. And from that omdoc, we generate yet two other representations of the knowledge. On the one hand, we feed RDF triples into a triple store for querying and for serving linked data clients. And we generate presentation-oriented documents in XHTML plus MathML that are not only readable for humans, but also contain semantic annotations given in OpenMath and RDFA to enable interactive services. Now let's go for the first example for semantic information retrieval. This is a front end that sits on top of our TNTBase database. This is the Moccasin query engine developed by Nikita Zhiltsov. And here we are going to search the collection of our lecture notes for examples about certain things. So I've already prepared part of the query. We want to search for examples that contain a certain text. And here we suppose we are interested in examples about equivalence relations. So we try to search for an example that somehow contains the words equivalence and relation in its text. So we submit this query. Moccasin queries the RDF store, to which we have committed the structural outlines of our lecture notes, and it returns some results. And we will now go to the first one. If we open it that way, we will open it for interactive browsing. Here we go. You see by the highlighting that we jumped to this example. This is an example about a particular equivalence relation. So just a short example, just a sentence of text without a formula. But you see there are also other examples with formulas. And now from that example, let us navigate further on. I click the right mouse button, open a context menu, and here we can navigate along the RDF relations that are in our triple store. And here, suppose we are interested in what this thing is an example for. So we see this example exemplifies something, and it exemplifies the thing we'll navigate to now. Now we are taken to this definition. In this case, the target of this link is in the same document. You may recall that from the STATE document that you've seen before, but it could as well be in a completely different document in our large document collection. So here we see a definition of several properties of binary relations with quite some mathematical formulas. And now let me demo another feature that is looking up definitions of mathematical symbols. So suppose a student doesn't know what that symbol means. Then the students can click on this and say, look up the definition of that symbol. Let me do this now. Then there is again, in the annotation of this formula, there is a semantic link to the identifier of the symbol, and in some other document there is a definition for that symbol, and this definition is what we show here in this pop-up. So this is the definition of the subset relation. Well, thanks for watching, and if you find that interesting, you can go to quark.info/linked lectures. This is our entry point that will continuously be updated, where you can find all details and demos about our lecture notes and the intelligent things that we do with them. And we'd be happy to invite you to build your own services on top of our lecture note collection. Thank you.